Hi, welcome to ChemTube channel. I'm Jae Wong. In this video, we are going to discuss the SBP model question set 2 in paper 2. Let's start. First, we look into the section A, structure questions. Question number 1. Diagram shows the electron arrangement of the atoms for the elements of sodium, argon, and chlorine. So based on the electron arrangement of the sodium, so state the number of valence electron. So we look into the elements of sodium here. So if we look into the electron arrangement, so first shell is 2, second shell is 8, last shell is 1. So electron arrangement is 2, 8, 1. So number of valence electrons, we look into the electrons at the outermost shell. So that is 1. Okay. Number 2, state the number of shells filled with the electrons. So here, if we look into the electron arrangement, so it's 2, 8, 1. So it has 3 electron shells, 3 shells occupied with electrons. So number 3, what is the property of the sodium oxide? So sodium oxide, sodium is the alkaline metals, right? So the property will be a base, base. Next, argon is chemically inert. Okay, state the use of argon. So what is the use of argon? So it's used to fill in the bulbs, light bulbs here. Okay, next, state the group for the chlorine in the periodic table. So the electron arrangement for chlorine is 287, right? 287. So the group will be group 17. Question number 2. Excess zinc powder, react with 20 cubic centimeter of 1 mole per cubic decimeter lead to nitrate solution in an experiment. So given to you the relative atomic mass for zinc, nitrogen, oxygen, and lead. Write a balanced chemical equation. So if you notice it, metal with the solution, so this is actually is a displacement reaction. So zinc powder, is a zinc metal, react with lead to nitrate, so it can displace the lead from the lead to nitrate solution. So zinc with lead to nitrate produces zinc, nitrate, and lead. So it is balanced already. So 2 marks. Now next, calculate the number of mole for lead to nitrate that is reacted. So you are given volume and concentration. So I think you know how to find the number of mole, right? So mv over 1000, so you get 0.02 mole. Next, calculate the mass of the zinc nitrate that is formed in this experiment. So meaning that zinc nitrate formed. So what is the mass? So we need to do the comparison. So lead to nitrate compare with this one is 1 to 1. So more or are the same. So mass of the zinc nitrate, so 0.02 mole times the molar mass for the zinc nitrate. Zinc nitrate, we have to total out zinc nitrate. So zinc is 65, nitrogen is 14, plus O is 16 times 3, then times 2 overall. So you get 189. So you get 3.78 gram. Unit must be stated correctly. So 2 marks. Question number 3. Given to you the number of proton and neutrons of atoms of element V, W, and X. X and Y. So given to you proton number and neutrons. So what is the meaning of isotopes? So isotopes, is the atoms of elements which have the same proton number but different nucleon number. Atoms of same elements which has a same proton number but different nucleon number. So which atoms are isotopes. So we go to find they have same proton number but different nucleon number or different neutrons. So if we look into the list here, proton number the same will be these two. Okay, neutrons is different. Okay, so it fulfills the definition here. So V and X. Okay. Now, state the isotope that can be used to treat the thyroid disease. So thyroid disease, okay, is like this. So actually using the iodine 131. 131. Now, referring to the atom W, write the electron arrangement of the atoms. So, electron arrangement for the atoms, okay, is 281, right? 281. Okay, W. Okay, so identify the position of W in the periodic table. So it's 281. So it's group 1 period 3. Oh, yeah. Okay, next, the empirical formula of the hexane is C3H7. So state the meaning of empirical formula. Okay, empirical formula. Okay, empirical formula, it shows the formula that shows the simplest whole number ratio of atoms of each element in the compound. Okay, so the words highlight with the red one is the keywords. Now next, the relative molecular mass of the hydrocarbon is 86. So determines the molecular formula. So given to you the empirical formula is C3H7. So we have to find the N. Okay, so it times N equals to 86. 86. So we need to find the N. So replace in the C and the hydrogen with the relative atomic mass. So you will get the N is 2. So meaning that the molecular formula times into it, so it becomes C6H14. So this is the molecular formula. Okay, diagram shows heating of copper to carbonate in the lab. Okay, so have a look on this video. So you can see the colors. Copper to carbonate is green color. So you heat it. Okay, then you produce a colorless bubble gas. So here actually is lime water. Okay, so we heat it. So you observe the color change. So initially it's green color, then slowly it turns to black color, right? So it turns to black color, and then here you observe, here you can see the lime water, it turns to cloudy, right? Excuse me. Okay, so step 1 observation for the reaction. So I think you can see it clearly. Yeah? So first you can write the lime water turns cloudy, or you can write here the green powder turns black, right? So write the chemical equation for the reaction occur. So copper to carbonate, it produces a copper to oxide and release the carbon dioxide gas. So the copper to oxide is black color. So copper to carbonate is green color. So that's why it turns, the green powder turns to black. Okay. Now state the qualitative and quantitative information that can be obtained from the chemical equation. So here you can write qualitatively the copper to carbonate and copper to oxide are solid. Carbon dioxide is gas. All reactants is copper to carbonate, and products are copper to oxide and carbon dioxide, right? Okay, you can choose any one qualitative information. Okay, for quantitative, so we relate it to the number of mole. So 1 mole of copper to carbonate produce 1 mole of copper to oxide and 1 mole of carbon dioxide. So this one is referring to the equation. Okay, question number 5. Diagram shows the graph of mass of calcium carbonate against time for the reaction between the calcium carbonate and hydrochloric acid. So you can see the mass decrease with time. Okay, now State the meaning of rate of reaction. Actually, here we can define it to two things here. So you can mention is decrease in the mass of the calcium carbonate per unit time, or increase in the volume of carbon dioxide per unit time. Okay, so what is the change that can be used to determine the rate of reaction? Actually, both can, but easier one will be the change in the volume of carbon dioxide per unit time. Will be easier. Okay, next, why does the curve in the graph remain constant after T1 seconds? So in this case, it remains constant because all the hydrochloric acid has been reacted completely, right? Next, write the chemical equation for the reaction. So calcium carbonate react with the acid, produce the calcium chloride, water, and carbon dioxide gas. So we need to balance the equation. So the hydrochloric acid need to times 2 here. Now next, 40 cubic centimeter of 0.5 mole per cubic decimeter. This is volume. This is concentration. Hydrochloric acid react with calcium carbonate. So here calcium carbonate is excess. So the time taken for the reaction to complete is 360 seconds. So calculate the volume of gas produced at the room condition. Okay. Now, first we need to calculate the number of mole. Okay, number of mole for the hydrochloric acid. Okay, we use the MV over 1000. You get 0.02 mole. Okay, so meaning that this one is 0.02 mole. Then how about the carbon dioxide gas, the volume? So we need to do the mole comparison. So 2 moles of hydrochloric acid produce 1 mole of carbon dioxide, right? So if 0.02, meaning that is 0.01 mole of carbon dioxide gas. So if we want to find the volume of gas, so mole times the molar volume. So you get 0.24 cubic decimeter. Unit must be stated correctly. Okay, so 3 marks. Question number 6. Okay, you are given 2 different types of compound, water and calcium oxide. Potassium oxide. So here, if we look into the diagrams, you will see if sharing of electrons. So this one is covalent, right? For if you see the charge ions, right? Okay, so this is ionic. Okay, so now based on the water electron arrangement, okay, write the chemical formula of the water molecule. So you have 2H, 1O, right? So it becomes H2O. So what is the purpose of oxygen atoms sharing electrons with hydrogen atoms in the water? Why they share the electrons? So no matter what elements are, if they want to share, they must achieve stable octet electron arrangement. Okay, so here should be duplet now because hydrogen atoms, right? So hydrogen atoms they share to achieve stable duplet electron arrangement. Okay, duplet electron arrangement should be the correct one. Okay, next, state the type of bond in the water. So just now we mentioned already is covalent compound, a covalent bond. For potassium oxide is ionic bond. Referring to the potassium oxide compound, write the formula. So if we look into the diagrams, is oxide, oxide ions, right? Oxide ions, all 2 negative. Write the electron arrangement for potassium atom. So potassium atom, it has from the diagrams there, we know it has achieved stable octet electron arrangement already. So it changed to ions already. So it's +1, right? +1. So meaning that initially it has 1 valence electrons. So it's 2881. Okay. So here is asking you the atoms, right? Okay. Next, based on the compound, compare the boiling point for the water and potassium oxide. So we know that ionic compound has a higher boiling point, right? Melting point and boiling point. So boiling point of potassium oxide is higher than water. Explain your answer. So ionic compound has higher melting and boiling point, right, than covalent compound. So how to explain? We relate it to the force of attraction. So van der Waals force of attraction between the water molecules are weaker compared to ions in the potassium oxide compound. They are attracted by strong electrostatic force. So strong electrostatic force is very strong, so a lot of heat is needed to overcome this force. So that's why the boiling point is higher compared to water. Okay, question number 7. Diagram shows the reaction involve the hydrocarbon P and alcohol. Okay, so hydrocarbon P here with the and the alcohol is here. So here, have a look here, C2H5OH. So C2H5OH here. So this is ethanol, right? So ethanol undergoes a reaction, so it forms a hydrocarbon P. So if hydrocarbon P means that is C and H only, right? So it becomes C2H4. So we know that if reaction 2, there is one reaction, change the alcohol to alkene, right? So this one we know it is dehydration. Okay, you can record down for example. Then here combustion, so it forms a carbon dioxide in water. Okay. Then alcohol react with the acidified potassium dichromatic solution. So this one is the what? This one is the oxidizing agent, right? So it's the oxidation. So it forms the acid R. Acid R meaning that this one is the ethanoic acid, CH3 COOH, ethanoic acid. So then ethanol and ethanoic acid react to form the colorless liquid. Okay, so here alcohol with carboxylic acid, we know it is forming the ester, so undergoes esterification. Okay, so based on the diagram, write the chemical equation for the reaction 1. So reaction 1 is the combustion, right? Okay, it's combustion. So it forms a it react with oxygen, produce the carbon dioxide and water. So we need to balance the equation. So C2H5OH, so C2, so carbon dioxide here times 2. Hydrogen, okay, is 5 plus 1, 6, right? 6. So 2 times 3, 6. So we check the oxygen, 3 plus 4, so 7. So we need to get 7 hydrogen here, so 1 already, so you need another 6. So 3 times 2, 6. So this is the balanced chemical equation. Okay, next, hydrocarbon P can be produced from the ethanol through the reaction 2. So what is the apparatus? So it's the dehydration, right? So dehydration, so we have to know how to draw the apparatus. So it's a combustion tube. Okay, you insert in the glass wool with the ethanol, then put in the porcelain chips here. Okay, then you need to heat the glass wool and the porcelain chips. Then the gas, the ethanol, you pass through the porcelain chips. Then you absorb the water. Then you produce the ethene gas in the test tube here. Okay. Now, step 1 observation in the reaction 3. So, is the orange solution turns to green. The acidified potassium dichromatics, it changed to green. Now, draw the structural formula for the liquid Q. Is the ester, right? So it's the ethyl ethanoate. So this is the structural formula. The functional group is carboxylate. Okay, next diagram shows the man is cutting the metal using the fuse containing the acetylene gas, C2H2. So name the homologous series state and a general formula for the acetylene gas. Okay, so alkene is alkyne, C2H2N minus 2. Okay, so N start with 2, 3, 4, and so on. Now draw the structural formula and set the name of the gas using the IPAC nomenclature. Okay, so for the ethyne, right? Ethyne. So it has the carbon-carbon triple bond, triple bond. So it's the ethyne, 2 carbons. Okay. Now question number 8. Okay, diagram shows the apparatus to determine the heat of neutralization between the hydrochloric acid and sodium hydroxide solution. So here you can have a look. Here is sodium hydroxide. This is hydrochloric acid. So strong acid, strong alkali. Okay, initial temperature 29 of hydrochloric acid, sodium hydroxide 29 also. So highest temperature is 35.5 degrees Celsius. So what is the meaning of the heat of neutralization? So it's a heat release when 1 mole of water, 1 mole of water is formed, okay, from the neutralization of hydrochloric acid and sodium hydroxide solution. Okay, so based on the experiment, calculate the heat change. So you will use the Q equals to MC theta. Okay, so it's 100 total volume is 50 plus 50, 4.2 times the temperature change. Theta is 6.5, so you get 2.73 kilojoule after we convert it to the kilojoule. Okay, next calculate the heat of neutralization. So we have to calculate the number of moles first. You get MV over 1000, you get is 0.05 mole. Acid also the same, 0.05 mole. So Q equals to MC theta, delta H equals to negative Q over the mole, right? So negative Q is 2.73 divided by the mole 0.05. So you get negative 54.6 kilojoule per mole. Negative shows the it is exothermic. Okay, so 3 marks. Now the experiment repeated using same volume concentration of ethanoic acid, okay, to replace the hydrochloric acid. So we know the ethanoic acid is a weak acid, right? So if you replace it with the replace the hydrochloric acid with the ethanoic acid, so what is the value of the heat of neutralization? So it will decrease, right? Decrease or less than negative 54.6 kilojoule per mole. Okay, explain your answer. So this one is very popular, Explain your answer. So ethanoic acid is a weak acid that ionizes partially in water, produce a low concentration of hydrogen ions, meaning that some of the acid still exists in the molecule form, right? So some of the particles remain in the forms of molecule. So part of the heat release during the neutralization is absorbed by the acid molecule to ionize completely. That is the reason. Okay, now draw the energy level diagrams for the reaction. So it's exothermic. So this is the correct one. Make sure that you label the energy. Okay, so the reaction, you can use a chemical equation or ionic equation. Okay, both can be accepted. And then remember to label the delta H equals to negative 54.6 kilojoule per mole. Okay, in next section, section B, we are going to discuss the essay questions, 2 essay questions. Okay, question number 9. Diagram shows the apparatus set up to electroplate an iron nail with silver. So here it has two cells, cell P and cell Q. So cell Q actually is the electroplating. So electroplating is a electrolytic cell. So in electrolytic cell, it needs the power supply or battery. So cell P becomes the battery or power supply to the cell Q. So it's a chemical cell. Okay. So state the type of cell for P and Q, compare and contrast in terms of energy change, positive terminal, half equation at anode, and observation at the cathode. So here we discussed already just now. Cell P will be chemical cell, cell Q is the electrolytic cell. So 2 marks here. So in terms of comparison or compare and contrast, so we can use a table to compare it. So have a look on this. So cell P is the chemical cell, cell Q is the electrolytic cell. So energy change for chemical cell, so it's a chemical energy to electrical energy. So for the electrolytic cell, it will be opposite now, electrical to chemical energy. Now from the two type of cell here, the positive terminal. So have a look here. So the zinc and the silver here. So zinc is it will become the negative terminal or anode in the cell P. This one is a positive. Okay. So when it connect to the iron nail here, so this one becomes the negative, this one becomes the positive. Okay. So here we look into the positive terminal. So it becomes, for cell P will be silver electrons. For cell Q also silver. So both are silver. Okay. Now at the anode, here this one you need to be careful. Okay, for the cell P chemical cell, the anode actually undergoes oxidation for both cell P and cell Q. So anode occur the oxidation. So oxidation occur at the negative terminal. So we call this is anode. Okay, but for the electrolytic cell or cell Q, the oxidation occur at the positive terminals here. So this one is called anode. Okay, so let's see what happens at the cell P anode here. So what happens with zinc? Okay, so zinc it will be ionized to form the zinc ions by lost 2 electrons. Okay, now for the anode in the cell Q, okay, silver is the active electrons. So during the electrolysis, so anode it will dissolve because it is not the inert electrons. So silver it will ionize. So by lost 2 electrons, so undergoes oxidation also. So remember, you can note down the anode it will undergoes oxidation. Okay, meaning that it will lost electrons or lost electrons. Okay, so at the cell P, so zinc it will lost electrons to form the zinc ions. For the anode, it will lost electrons to form the silver ions. For the cathode, okay, for the cathode, so cathode here for the cell P cathode, this one undergoes oxidation, reduction. This one also undergoes reduction. So this is a cathode. Okay, so let's see the cathode here for cell Q. Okay, so cell P first. Okay, so at cell P, the cathode here, what happens here? So inside there we focus to the positive ions inside the electrolyte. So inside the electrolyte we have hydrogen ions, no? So meaning that the hydrogen ions you gain electrons to form the hydrogen. So hydrogen it must be diatomic, right? So 2 hydrogen ions, so 2 electrons. So this is a half equation. At the cathode at the cell Q, okay, so you have the positive ions will be silver and hydrogen. So silver will be selectively discharged, huh? So again electrons, so it forms a silver metal, huh? Okay, so here you know the observation, hydrogen gas and silver. So what is the observation? You cannot write hydrogen gas is produced and then silver is produced for the observation. Okay, it's not correct, huh? So what is the color of the hydrogen gas? So it's colorless bubble gas. Silver, so silver is silvery solid, huh? Okay, or silvery solid or shiny gray solid is deposited. This one is colorless bubble gas release. Okay. Now calculate the maximum mass of the silver deposited on the iron nail. So this one we can calculate the number of mole for the silver ions first. So MV over 1000 you get 0.05 mole. Okay. So silver ions produce the same number of mole for the silver. So if we do the mole ratio, will be the same, 0.045 mole of the silver. So if we want to find the mass mole times the molar mass, so it's 5.4 gram. Okay, next diagram shows the apparatus for the experiment to investigate the displacement of halogen, okay, from their halide solution. Okay, so here the experiment carried out using different halogens and halides solutions. Observation are recorded in the table. So here the 111 trichloroethane actually is used to detect whether the halogen, which halogen is formed in the reaction. Okay, so here bromine put into the potassium iodide. Okay, so it forms a purple color. Okay, for the layers of 111 trichloroethane. For iodine put into the potassium bromide. Okay, also you produce the same observation as this one. Okay, but in terms of reaction, let's have a look. Bromine put into the potassium iodide, actually this one it can displace, so it forms a iodine. Iodine is formed, so meaning that you can see the purple color form. But for the iodine here, okay, when you react, okay, meaning that this one iodine remains inside here. So in other words, the cell 2 no reaction, the set 1 got reaction. Okay, so this is the main concept. So have a look on this. So based on in terms of change in the oxidation number, explain why the observation in set 1 and set 2 are similar in 111 trichloroethane layer. Okay, so 8 marks here. So in set 1, bromine is more reactive or electronegative than iodine. Okay, so bromine it can displace the iodine from the potassium iodide solution. and oxidation number is changed from the -1 to 0. So iodide ions is oxidized, so you can put in the half equation. 2 iodide ions, it forms the iodine by lost 2 electrons. So undergoes oxidation, so the oxidation number, this one is -1, this one is 0, okay, because it is molecule form. So displacement reaction occur, so that's why you observe the purple color is formed in the 111 trichloroethane layer there. For set 2, iodine is less reactive or electronegative than bromine, so it cannot displace the bromine from the potassium bromide solution, so reaction does not occur. So that's why the purple color, it remains here lah, okay, because there is no reaction in the set 2. Okay, table shows a list of apparatus and materials, U-tube, carbon electrodes, connecting wires, galvanometer. Then materials or chemicals, potassium iodide solution, acidified potassium manganate 7 solution, and then sulfuric acid as the electrolyte. Okay, draw a label diagram to show the apparatus to investigate the electron transfer at a distance. So the diagram must include the apparatus and materials given, and then mark the direction of the electron flows. So 2 marks. So here, for the electron transfer, you must use a U-tube. So we have a look here. So U-tube, okay, electrodes put in, and then the potassium iodide solution and acidified potassium dichromate 6, manganate 6, 7 solution, and then sulfuric acid. Okay, you have to label all that correctly. Okay, here the stopper must be cannot be fully immersed into the U-tube here. Okay, then connecting wire, then galvanometer. All the material apparatus must be put and then label it correctly. Okay, then the electron transfer, right? Electron transfer. Okay, acidified potassium manganate 7 is a strong oxidizing agent, undergoes reduction, right? Okay, reduction. Reduction is gain electrons, right? So gain electrons, so meaning the electrons must be come from or released by the reducing agent. Okay, so electrons flows from the reducing agent to the oxidizing agent. Okay, iodide will lost the electrons, the one we discussed in our previous question. So 2 marks in this question. Okay, question number 10. In an experiment, 50 cubic centimeter of 0.1 mole per cubic decimeter ethanoic acid react completely with X gram of sodium hydroxide, and it is dissolved in 100 cubic centimeter of the solution. So you need to calculate the value of X. Given to you, the molecular mass of the X is 40. Okay, so 4 marks. So first we need to write the chemical equation. So ethanoic acid react with sodium hydroxide, so produce the sodium ethanoate and water, right? Now next step, we can do the calculation for the number of mole for the ethanoic acid. So MV over 1000, you get 0.005 mole. Okay, so if we compare it with the sodium hydroxide, the mole ratio is 1:1. So the mole for the sodium hydroxide is also 0.005 mole of the sodium hydroxide. So if we want to find the mass X gram of the sodium hydroxide, so mass mole times the molar mass, so you get 0.2 gram. Table shows the type of particles present in the glacial ethanoic acid. So glacial ethanoic acid in solvent L and glacial ethanoic acid in solvent M. So have a look here. in the glacial ethanoic acid, the acid is still exists in the molecule form. Okay, so now we look into the ethanoic acid. In solvent L, you can see some of the molecules it change or ionize to form the hydrogen ions, right? So meaning that the solvent L enable the acid to ionize, but in the solvent M, okay, the acid is still in the molecule form, so meaning that it is not able to ionize the ethanoic acid, okay, for the solvent M.
Why glacial acetic acid does not change blue litmus paper red? Glacial acetic acid is a dry acid. Though acetic acid is in liquid form, but there is no water molecule present. Therefore, the acetic acid molecule does not dissociate to release the hydrogen ion unless a substance like water molecule ready to accept the hydrogen ions. When water is added, the acetic acid molecule breaks up and releases hydrogen ion. The hydrogen ion then accepts the water molecule to form hydrozonium ion, which makes the liquid acidic, thus changes the blue litmus red.
So, suggest the name of the solvent L and solvent M. So explain your answer for marks. Okay, so solvent L should be water, right? Solvent M should be organic solvent. So you can use any one of the organic solvent here: methylbenzene, propanol, acetone, chloroform, 1,1,1-trichloroethane, all can be used. Okay, now explain your answer why ethanoic acid ionized in water, then hydrogen ions is present. Ethanoic acid does not ionize in organic solvent, so no hydrogen ions is present. Okay, so very simple. Now, write a balanced chemical equation for the reaction occur when the magnesium is added to glacial ethanoic acid in solvent L, so in water, meaning that it can react, okay, with the magnesium here. So magnesium react with the ethanoic acid, so it forms a magnesium ethanoate and hydrogen gas is released. Okay, so you need to balance the equation times 2. C. Diagram shows the pH value for hydrochloric acid and ethanoic acid. So you have a look here. So hydrochloric acid concentration 0.1 mole per cubic decimeter. Then this also hydrochloric acid but less concentration. Okay, so pH is 1, this one pH is 3. Okay, then if you compare with ethanoic acid, same concentration with the first one, but pH is 5 for ethanoic acid. Okay.
We have learned that acids can be classified as strong acids and weak acids. The strength of an acid depends on the degree of dissociation of the acid in water. When a strong acid dissolves in water, all the acid molecules dissociate to form hydrogen ions. Thus, the concentration of hydrogen ions in the solution is high. When a weak acid dissolves in water, only a small amount of the acid molecules dissociate to form hydrogen ions. Thus, the concentration of hydrogen ions in the solution is low. Now let us compare the pH of some acid solutions of the same molar concentration to determine which acids are strong and which acids are weak. Drag the slider across the pH scale.
Now compare the difference of pH value for both hydrochloric acid with different molarity. So here we know that concentration of hydrogen ions in 0.1 mole per cubic decimeter hydrochloric acid is higher than 0.001 mole per cubic decimeter hydrochloric acid, right? So the higher the concentration of hydrogen ions, the lower the pH, huh? Yeah, so 2 marks. Okay, for the explain the pH value for the hydrochloric acid and ethanoic acid are different, although they have the same molarity or same concentration, right? Okay, so this one we have to explain the strong acid and weak acid, in order to explain the pH. So first we mentioned about hydrochloric acid is a strong acid. So strong acid ionized completely in water, right? And when it ionizes completely in water, the concentration of hydrogen ions will be very high. Okay, and pH value is lower, that is 1 in this case. Meanwhile, for the ethanoic acid is a weak acid, so it ionizes partially in water. So when ionized partially in water, so the concentration of hydrogen ions will be lower. So the lower the pH value, lower the concentration of hydrogen ions, the pH value is higher. Okay, so last part of this video is the section C, the essay question, one essay question. Question 11, diagram shows the two different reactions. So reaction 1, magnesium powder put into the hydrochloric acid. So observation, colorless bubble gas release. Reaction 2, magnesium put into the copper 2 sulfate solution. So it forms a brown solid. So we know that reaction 2 is the displacement reaction. Okay, now based on the diagrams, names the solid brown solid formed in the reaction 2. So we know that the brown solid here will be the copper metal. So choose which reaction is more suitable to prepare the salt and write the overall ionic equation for the reaction. So during the in the preparation of the salt, right? Okay, we will prefer use the reaction between the metal with the acid instead of the displacement reaction. So reaction 1 is more suitable. Okay, so magnesium powder react with the hydrochloric acid, so it forms the magnesium chloride and the hydrogen gas. So if we cancel the chloride ions, then it will form the hydrogen ions and then the magnesium ions. So this is the ionic equation. Okay. Diagram 11.2 shows a series of reactions used to produce a salt W. Okay, so here first we look into here the solution, blue solution of salt Q. Okay, so undergoes the reaction X, so it produces a green precipitate, and then the green precipitate here react with the acid M, so it forms a salt W. Okay, so here name the reaction X, suggest the L and M. So here if we look into details, right? Okay, so the blue solution here is a solution, then after the reaction X, it forms a precipitate. So we know that this reaction actually is a precipitation reaction or double decomposition reaction. So how to determine the solution L? Okay, so we look into the colors. So here blue solution, so we know it must consist of copper 2 ions. Okay, then green precipitate, we know that if copper copper metal salt with green color, it must be copper 2 carbonate, correct? So it's green color. So what is the solution L? So solution L must consist of the carbonate ions. So what carbonate ions is soluble? So it's a SPA, SPA, sodium, potassium, ammonium carbonate. Okay, so solution L can be sodium carbonate, ammonium carbonate, or potassium carbonate. Okay, SPA. Now after we react with, we produce a copper-2 carbonate, right? React with the acid, produce a salt, right? So this one, this acid actually can be any acid will do. So here nitric acid hydrochloric acid or sulfuric acid, okay, all can be accepted. Okay, next describe a confirmatory test for the cations in the solution W. So solution W, it consists of copper-2 ions, right? So how to do the confirmatory test? So let's have a look on the video. So first we measure and pour 2 cubic centimeter of the solution W. Okay, here actually solution W, you can choose any one of these also can. Okay, and then put into a test tube. Then add 2 cubic centimeter of sodium hydroxide solution, or you can use ammonia. It's up to you which one you want to use into the test tube until excess. So if you use a sodium hydroxide solution, so the blue precipitate insoluble in excess sodium hydroxide solution. But if you use the ammonia solution, so blue precipitate soluble in excess ammonia solution. Okay, so we confirm the presence of copper-2 ions. Okay, so next, based on the reaction Y, describe an experiment to prepare the dry salt W. So your description should include the following. You should include the chemical equation involved. So 10 marks. So now I show you one video how to prepare the salt. So here is using the calcium carbonate. So later on in the salt W can be copper-2 salt. Okay.
For the preparation of calcium chloride crystals, the apparatus required are a 250 milliliter beaker, a spatula, and a glass rod. The materials required are calcium carbonate powder and 50 cubic centimeters 1.0 mole per cubic decimeter of dilute hydrochloric acid. Now, let's prepare the salt solution. Using a spatula, add calcium carbonate powder into the dilute hydrochloric acid. Stir the mixture using a glass rod. What can you observe? Effervescence is seen and a gas is released. Can you name the gas released? Let's run a suitable gas test. Now, can you name the gas? Carbon dioxide gas is released. Now, add in excess calcium carbonate powder and stir well. Why do we have to add in excess calcium carbonate? This is to ensure all the acid has completely reacted. We have now obtained the calcium chloride salt solution. First, filter the mixture to remove excess calcium carbonate powder. leave the excess calcium carbonate powder on the filter paper. The filtrate calcium chloride solution is collected in the beaker. Now, let's proceed to the next step. The next step is the evaporation and crystallization. Gently heat the calcium chloride solution in an evaporating dish until it is 1/3 of its original volume. Then, leave the saturated solution to cool to room temperature for the crystals to form. Now, let's proceed to the next step. The next step is to remove impurities from the chloride crystals. This can be done by squirting a small amount of distilled water. Now, let's proceed to the next step. The final step is drying the crystals. Dry the calcium chloride crystals by placing them in a desiccator. Finally, we have now obtained a sample of calcium chloride crystals.
So, based on the reaction Y, okay, so we can start to do the planning here, describe the experiment. So first measure and pour 50 cubic centimeter of 1 mole per cubic decimeter. So you can choose any one of these acid. So let's say we choose nitric acid. Put into the beaker. So heat the nitric acid gently. Then add the carbon 2 carbonate powder liter by liter into the beaker until excess. Stir the mixture with a glass rod. Then filter the mixture. Then transfer the filtrate to the evaporating dish and then heat until saturated. Okay, how do you know it is saturated? It's roughly 1/3 or from its original volume. Then let it cool down to form the salt crystals, and then press or dry the salt by pressing them between 2 filter peppers. Okay, so must be at least 2 filter peppers. Okay. Then the chemical equation, so let's say we use the nitric acid. So carbon 2 carbonate react with the nitric acid. So it produces carbon 2 nitrate, carbon dioxide and water. So this is the correct chemical equation. So if you use the hydrochloric acid, this is the equation. And if you use the sulfuric acid, this is the chemical equation. Okay. So that's all for the SBP model questions in paper 2 under set 2. So like this video, share this video with your friends, and then good luck to all the SPM candidates. Okay, all the best to you. God bless.